Welcome back to Just Academy Mathematics YouTube channel, where we make you a mathematics genius. You are interested in learning eigenvalues and eigenvectors, then I want you to stick to the end of this video, because in this video I'm going to be showing you in a very simple way how to answer questions related to eigenvalues and eigenvectors. Okay, let's go straight to business. When we talk about eigenvalues and eigenvectors, definitely we are talking about it's still an extension of matrix. So we are considering eigenvalue and eigenvector for 2x2 matrix, as you can see. So we have our first example that says find the eigenvalue and the corresponding eigenvectors of this matrix A equals to -2, 3, 5, and 0. So the very first thing you are going to do, let me first start by splitting this, because I'm going to utilize all this space within the course of this solution. So let me split it now so that I will not have to waste it. Okay, the very first thing you are going to do, you are required to do, is to state the eigenvalue characteristics equation, which is constant, is given. So there is what is called eigenvalue characteristics equation. Eigenvalues characteristics equation. This eigenvalue characteristics equation is given as the absolute value of matrix A minus the eigenvalue representative, which is lambda in this case, times the 2x2 identity. Since a matrix A is 2x2 identity, equals to 0. So this is I. This I stands for the identity of unit matrix of matrix A, or matrix A 2x2 identity, which is 1, 0, 0, 1. This A is this matrix you are seeing here. This lambda represents the eigenvalues. So this is the characteristics equation. So this is what we want to solve for now. Are you getting it now? So without this absolute value also stands for determinant, of course, you know. So let's get the value without the absolute value. Let's get the value of A minus lambda times identity. I get what I'm saying? Let's get that first. So what is A? Obviously, A is what? A is -2, 3, 5, 0 minus lambda times identity here is what? 1, 0, 0, 1. Now, when you operate this, what are we expected to get? We're expected to get that lambda times 1 will give me lambda. So you have -2 minus lambda, -2 minus lambda. Then here you have 5, because lambda times 0 is 0. So 5 minus 0 will still give you what? 5. Then here you have 3. While here you have minus lambda. Of course, you know how we got that now. Because this times this will give you lambda. This is 0. 0 minus lambda will give you minus lambda. So A minus lambda times identity gives you this. So the next thing now is to find the determinant of this equals to 0, which is this statement here. Are you following? So we are now looking for the determinant of -2 minus lambda, 3, 5 minus lambda equals to 0, which is this statement here. So we find the determinant of this now. And now what we're actually looking for now is lambda. once we get the lambda, this lambda represents the eigenvalues. So of course, you know that determinant, this will times this, minus this will times this. We've done determinant before. So I have minus 2 minus lambda times n minus lambda, then what? Minus, then what again? 5 will times what? Will times 3. 5 times 3. So this times this minus this times this equals to what? 0. So if you open the bracket, we are going to get that rather 2 lambda plus lambda square minus 15 is equals to 0. If you look at this, this is now a quadratic function which can be written as lambda square plus 2 lambda minus 15 is equals to 0. So if we factorize this, two numbers will add to give us 2 times to give us minus 15. What are they? That should be what? That should be plus 5 minus 3. Plus 5 minus 3 will give us 2. Plus 5 minus 3 will give us what? Minus 15. That is just mere factorization now. So when you factorize this now, you are going to get what? You are going to get lambda. What did I say? That they are the two factors. Minus 3, then what? Plus 5 equals to 0. If you open this bracket now, you get back to this. So this is just factorization of quadratic. Okay, I believe you know that, but even if you don't know that and we have not treated it, you should be treating quadratic very soon if we have not. Okay, now let's proceed with this now. So from here, we can now conclude that lambda minus 3 is equals to 0, or lambda plus 5 is equals to 0. So lambda is equals to 3, or lambda is equals to what? Is equals to minus 5. Are you seeing it now? So what are we saying? We conclude, therefore, eigenvalues, the eigenvalues are what? Minus 5 and 3. They want us to find the eigenvalues. We are telling them now that the eigenvalues are minus 5 and 3. I get what I'm saying? So that is the two values. Now, the confusing part is eigenvector. Most students get confused with eigenvector. So we're going to be taking on eigenvector now. I believe this is very clear. So this one is simple. Just remember this characteristics equation. Then you solve for lambda to get your eigenvalues. I get what I'm saying? So the next step is getting eigenvector. So for eigenvector, we know that A minus lambda times identity times the vector is equals to 0, where V is vector, where V is equals to vector. So this is the vector equation. That this, your characteristics equation here, without not the determinant of the character, not without the determinant sign, without the absolute value sign, this one here times the vector must always be equals to what? 0. Are you getting it now? So if we quote these statements here, where the vector will be represented with, remember that this one now is the same thing as this. Look at it here. That is, this is what I mean. Minus 2 minus lambda 3, 5 minus lambda, which is this one. You know, we have solved for it before, and we got it here. Look at it here. Now, let the vector be what? Be x1 and x2. The v be x1 as is equals to 0. And 0 can be represented in matrix form like this. Are you seeing it now? So our work now is to find the vector for each of the value. So I can come and say eigenvector for lambda equals to -5. Then I will also solve for eigenvector for lambda equals to -3. But let's take that of -5 first. I'm splitting it because I want to put everything here. Okay, now, so vector for lambda equals to -5 means when this lambda is -5, then this equation you are seeing here will now be -2 minus lambda. What is lambda? -5. And -2 minus lambda. Minus times minus is plus. So -2 minus lambda will be -2 plus 5, because this is minus lambda. Minus -5 will give you +5. Minus times minus plus. So -2 plus 5 will give me what? 3. Then remember, here is still 5. Then here is 3. Then minus lambda. Minus lambda. Minus 5 will give you what? +5. So the vector representative S1, X2 is equals to what? 0, 0. So follow the procedure. So what we'll do is that we derive 2 equations. You know how to multiply matrix now. Row times column, row times column. If you split this to a system of linear equation, 3 will times S1, we have 3x1, plus 5 will times x2, we have 5x2, is equals to 0. We can call this equation 1. We do the same thing. 3 times s1, again, we have 3x1, plus 5 times s2 will give us 5s2. That is for the second line, second row, equals to what again? 0. Equation what? 2. So what we do now is that from equation 1, let's make x1 the subject of the formula. So to make s1 the subject of the formula, we have 3x1 is equals to -5x2. Divide both sides by 3x1. You have that x1 is equals to what? -5 over what? 3, then what? x2. So this is what we get after we have made s1 the subject of the formula. In the same way, you make s2 the subject of the formula from equation 2. From equation 2, let's make x2, or from equation 2 rather, from equation 2. Listen now, we have derived equation, we have made s1 the subject of the formula from equation 1. This is what s1 is. Now we are going to put this equation now, this s1 equals to this in equation 2. It's just like substitution method. So in equation 2, anywhere you see x1, you replace it with the whole of this, so that we can find s2. So in equation 2, 3x1, in the place of s1, I will replace with it -5 over 3 x2 minus equals to what? -5 x2. By the time you bring this one here, you get 5x2. So you put this equation s1 here in equation 2. You bring this one here. And you get what I'm saying? Now, with that, of course, you can see that 3 can cancel 3. If 3 cancel 3, you have -5x minus 5x. So we can actually conclude that x2 is equals to what? 1x2. Are you following? The value of s2 is equals to 1s2. Now that we know that the value of x2 is equals to 1x2, we can now present the vector like this. Therefore, v1, which is vector for vector for eigenvalue of s minus 5 will now be what? You put the value. The first vector, which is s1, this first one here, is what? Minus 5 over what? 3 times s2 and 1x2. Because everything has to be in terms of s2. s1 in terms of s2, s2 in terms of s2. Now, if you say let x2 be equals to 1, you get the real vector. That the real vector now is what? Minus 5 over 3 times what? 1. This is the vector. This is the vector. This is the vector when the eigenvalue is what? Minus 5. Let me explain something, because there are other ways to do it anyway, but this is the method that I know is very easy. So your work is not actually to find the value of x1 and s2. What you need to do is to find one in terms of the other. Like we'll find x1 now in terms of x2. The same way you find x2 also in terms of the x2, then let the x2 be a unit like 1. Then you will now notice that you get your vector. So let's do with the other one. I think that will help it to be clearer. Let me shift it a bit. So we do the same thing now. Eigenvector for lambda equals to 3. Let's see what happens here. So when it is for lambda equals to 3, remember, in the place of this lambda, we'll put 3. So if here is 3, you get minus 5 there. Minus 5, 3, 5. Then when lambda is 3, minus 3. Times in the eigenvector representative s1, x2 is equals to what? 0 and 0. So the same procedure again. We derive an equation, a linear equation, by expanding the bracket, row times column, of course. Minus 5 times 1x minus 5x1 plus 5x2 equals to 0. This can be called equation 1. We do the same thing again. 3 times x, 3x1 minus 3x2 is equals to 0. This can be called equation 2. If you are following the procedure here, remember the next thing is to, from equation 1, let's make S1 the subject. If you make S1 the subject, you move this one here now, of course. So you will now have minus 5x1 is equals to minus 5x2. So for S1 to stand alone, you divide both sides by minus 5. So x1 is equals to minus 5 of, which is minus 5 over 5 now, then x2. Are you following now? Which is the same thing as what? 1x2. Let's leave it as 1x2. So this is the value for x1, 1x2, in terms of x2. So we're going to find s2 in terms of s2 again by putting the value of x1 in equation 2. Since we derive this one from equation 1, we put this in equation 2. In that case, anywhere we see s1 in equation 2, we'll put 1x2. Are you following now? So in the place of, from equation 2 now, from equation 2, so we have 3x1. What is x1? You replace it with 1x2. Equals to, when you bring this one back, it will give you positive. If you bring this minus 3x2 here, become plus 3x2. Can you see that now? This time this will give you 3x2. So you divide both sides with 3. You have x2 is equals to what? Of course, when you divide outside with 3, you have what? 1x2. So this is the value of x2 in terms of x2. x1 in terms of x2, x2 in terms of x2. Therefore, the vector when the eigenvalue is 3 is what? The first one is what? S1 is 1x2 and then what? 1x2. Can you see that now? So you let x2 now be equals to 1. So the vector is simply 1 and 1. So in other words, this is the conclusion. Can this thing be captured completely? Okay, this is the conclusion. The eigenvalues is -5 and 3. The eigenvectors are -5 over 3, 1, and 1 and 1. The vector for the eigenvalue of -5, this is the vector. The vector for eigenvalue of 3, this is the what? Vector. Okay, that is it for that one. Let me try and solve. Okay, so we have another example just to drive this eigenvector for 2 by 2 matrix home. Now we have another question. We want to find the eigenvalues and the corresponding eigenvectors of this matrix. This is our second example now. So the same thing is applicable. You start by stating the characteristics equation for eigenvalues. The eigenvalues characteristics equation, which states that matrix A, determinant of matrix A minus lambda, which represent the eigenvalue, the determinant of this is equals to 0. This is the characteristics equation. You always quote this because this way is what you are following to find the eigenvalue. The lambda now is the eigenvalue. The eigenvalue now, the lambda here now represents the what? The eigenvalue. So what we now need to do now is to get the value of A minus lambda times identity. That is what is inside this absolute value sign. And what is A? Matrix A is -3, 4, then -2, 6, then minus lambda times what is identity? 1, 0, 0, 1. This is identity. So what will this give you? Let's find out. -3 minus lambda times 1. Lambda times 1 is minus lambda. Minus, so here will give us -3 minus lambda. How about -2 times lambda times 0 will give us 0. Here will remain -2. 4 times the same thing here will remain 4. While 6 times, rather 6 minus lambda times 1 will give us what? 6 minus lambda. So this statement now, look at the values here. It is now the determinant of this equals to 0 that we are to solve for to get the values. So we'll now come and say -3 minus lambda, 4 minus 2, 6 minus lambda. The determinant of this equals to what? 0. This is what we are solving for now. So this lambda represents the eigenvalues. Of course, you know how to find determinants. To find the determinant of this now, this will times this, minus this will times this, which is -3 minus x lambda times 6 minus lambda minus then -2 times 4 is equals to 0. So we expand. Minus 3 times 6 is what? Minus 18. Minus 3 times minus lambda plus 3 lambda minus 6 times lambda minus 6 lambda minus lambda times minus lambda plus lambda square plus 8 is equals to 0. So if you balance up this quadratic equation, obviously it's a quadratic equation. You have lambda square plus 3 minus 6 will give us minus 3 lambda minus 18 plus 8 will give us minus 10 is equal to 0. So the next thing is to factorize this. We need two numbers that will add to give us minus 3 times to give us minus 10. Minus 3 times to give us minus 10. That should be 5 and 2. And that should be minus 5 plus 2. Minus 5 plus 2 will give us minus 3. Minus 5 times 2 will give us what? Minus 10. So we replace this now. Lambda minus 5, then lambda plus 2 equals to 0. The expansion of this bracket gives you this. This is just quadratic equation now. So from here, you know that lambda minus 5 is equals to 0, or lambda plus 2 is equals to 0. And we can now conclude that lambda is equals to 5, or lambda is equals to minus 2. Does that make sense? So we therefore conclude that the eigenvalues are, what are the two eigenvalues? 5 and negative 2. This is the eigenvalue. Can you see? It's all about procedure, you get it. Now, like I said, the issue is not always with the eigenvalue. The issue is with the eigenvector, because that is the one that most people miss. Most people always miss and get confused when it comes to eigenvector. Now, what do we do to find the eigenvector? Simple. First, remember that for eigenvector, what is the eigenvector equation? That the matrix A minus lambda times identity times the vector must always be equal to what? 0. So whatever is V times this expression here will always give you 0. That is the eigenvector, where V stands for vector. So remember that this A minus lambda times identity is this here. So in other words, we are saying that minus 3 minus lambda 4 minus 2, 6 minus lambda, that is this times what? Vector. Let the vector be x1 and x2. Will always be equals to what? 0, 0. This is what we are going to use now to find the vector for both. So we are going to find the vector for when lambda is 2, when the eigenvalue is 5. We'll find the vector for it, corresponding vector. Then the corresponding vector for minus 2. So let's split this to enable us to do that. Okay, now let's start. Eigenvector for lambda equals to 5. That is, to get the corresponding vector when lambda is 5. Remember, this is the equation we are using now. So anywhere you see lambda here, you put 5. If I put 5 here, that place will turn to minus 8, 4, then minus 2. If I put 5 here, here will be 1. Then times in what? x1, x2 must be equals to what? 0. So I say we rewrite this in form of linear equation, in form of a system of linear equation. Of course, row with times column, row with times column. So minus 3 times x1 will give me minus 3x1 minus 2 times s2 minus 2x2 is equals to 0. This can be regarded as equation 1. We'll do the same thing with the second row. 4 times x1, 4x1, 1 times x2 plus x2 is equals to 0. This can be regarded as equation 2. So now, from what I told you from the last example, we make x1 the subject from equation 1 in terms of x2. So this is what I mean. From equation 1, let's make x1 the subject. Okay, I just noticed a small error now. Remember, okay, when this lambda is 5 here, 5 here, minus 3 minus 5 will give us minus 8, not 3. So here is minus 8, here is minus 8, just to clear the air. I just noticed that. I think every other thing is in order. When lambda is 5, this will give you 1, so it's okay now. Now, from this equation 1, let's make S1 the subject. And to do that, what do we do to make S1 the subject? We have that minus 8x1 is equals to, bring this S2 here. You have 2x2. For S1 to stand alone, we divide both sides with minus 8. We have minus 2 over 8, then what? X2. Are you following now? Which you can reduce into x1 is equals to minus 1 over 4 x2. So this is now the value of x1 in terms of x2. Remember, your assignment is not to know the real value of to start finding x2, or find one of them in terms of the other. So since we have gotten s1 in terms of s2, we will also find x2 in terms of x2 by substituting x1. Anywhere we see s1 in equation 2 now, equation 1 gave birth to this. So anywhere we see s1 in equation 2, we will replace it with this. So this is what I mean now. From equation 2, anywhere we see x1, that is 4x1. In the place of x1, I'll write minus 1 over 4 x2. Are you with me now? Plus, or rather, equals to, if you bring that one there, you have minus x2. Now, 4 will cancel 4. We are left with minus x2 here. So if you divide, we can say minus 1x2. So if you divide both sides with that one, you have that x2 is equals to what? Minus 1 divided by minus 1 will give you 1x2. So this is the value for s2 in terms of x2. So you now come and present the vector that v1 is now equals to, what is the first value? Minus 1 over 4 x2, then 1 x2. Then this x2, let the x2 be 1 in order to do away with the s2. If the s2 is 1, then v1, the corresponding vector for 5 will now be what? Will now be minus 1 over 4 and 1. This is the corresponding vector to the eigenvalue of what? 5. Is that clear? Okay, the same thing. Let me shift this side. Our focus is here now. The same thing is to get the corresponding vector for eigenvalue of minus 2. Now we'll say eigenvector for lambda equals to minus 2. So this time around, anywhere we see lambda here, we put minus 2. So remember, minus 3 minus times minus 2. Minus times minus 2 will give you plus 2. Minus 3 plus 2 will give you minus 1. So this is minus 2. Then we have 4. And we have 6 minus times minus 2 will give you 8. Are you seeing it now? Times x1, x2 must be equals to 0, 0. So again, we derive the equation row times column. Minus 1 times x will give me what? Minus x1 minus 2x2 is equals to 0. We call this equation 1. We do the same thing for the second line. 4x1 plus 8x2 is equals to 0. Equation 2. So from equation 1, simple, from equation 1, we find x1 in terms of x2. So we have minus x1 is equals to 2x2. We divide both sides with this negative 1. So x1 is equals to minus 2x2. This is the value of x1 in terms of x2. So anywhere we now see s1 in equation 2, we replace it with this. So from equation 2, 4x1, in the place of x1, I'll write minus 2x2 is equals to, bring this one here, you have minus 8s2. So if you open this bracket, of course, you know you are going to get what? Minus 8 also. So you divide both sides with what? Minus 8. So you have that x2 in terms of s2. Minus 8 divided by minus 8 will give you what? 1x2. Are you seeing it now? So now that we know the two values in terms of x2, we therefore say that the vector will be represented as minus 2x2 and 1x2. So let x2 be equals to 1. So the vector, when the value is minus 2, is simply minus 2, 1. This is the second vector. So that is the procedure of finding eigenvector. So there is nothing there. This is the procedure. This is the eigenvector for the value, for the eigenvalue of 5. And this is the eigenvector for the eigenvalue of minus 2. So it's just all about understanding the process and the procedure. The getting the eigenvalues is not a big deal. But this is one that is a bit confusing. There is another way, but I prefer this method. So in our next class, I'm going to be showing you the 3x3 matrix, finding eigenvalue and vector for a 3x3 matrix. Don't miss that. And remember, if you want me to teach you this or any other topic in maths, just send me a web message via WhatsApp. The WhatsApp contact is showing. Thank you. If you are not following us on our social media platform, do so. All the handle, both YouTube and Facebook, is Just Academy Mathematics. Just Academy Mathematics. See you again.